Well, good night. Yours truly, Professor Dr. Dolphy Gilpin. Tonight we're continuing with our periodic table. And we've reached element 19, potassium, with an atomic number of 19 and atomic mass of 39.08. There are three isotopes of potassium, 39, 40, and 41. See which one is more stable. Alright, let's try to pluck it this from the our deck. Yeah, I see we have neon, beryllium, but that was out. Iodine is one of the special ones. Mercury, helium. Mercury is one of the special ones. Phosphorus within. Okay, here we have potassium, 19. Okay, so we have potassium atomic number 19. An atomic mass of 39.018, both sides. And it has an electronics configuration of neon 4s1. As we turn to a little notebook here. That's calcium, that's 20. Potassium is argon 4s1 rather. So that's a correction. Argon 4s1, atomic mass of 39.098, an atomic number of 19. K is a soft and white silvery metal, soft, good conductivity, and fairly good conductor of electricity. It's the seventh most abundant element in the Earth crust. So those are little notes on potassium there. And we have this isotope, K39, K40, and K41. And we see K40 is radioactive. Radioactive here means it can release alpha, beta, and gamma particles. Alright. So it's right after argon, the inert gas, and that's why we say we could write it as argon 4s1. Well, let's get some more reactions of potassium. Okay, alright, reaction with the halogens family. We have some of them, 2 potassium plus chlorine, give it 2 potassium chloride. We have 2 potassium plus 2 bromine, 2 bromine potassium bromide. And likewise it would be with iodide, 2 potassium plus I2 will give you 2 Ki, and fluorine. All of these are in the halogens group here, and all of reaction will be similar. But one of the most famous reactions back there in high school and up there in college, we would see the potassium reacting with water to give potassium hydroxide and hydrogen. and heat is given out. Therefore, that's an exothermic reaction. Delta H is negative. So 2K plus 2H2 will give you 2 KOH, potassium hydroxide. And we could go to a very famous reaction, potassium permanganate. When you eat it, gives a potassium manganate and oxygen. And this was one of the ways to produce oxygen in the laboratory, in which there was a catalyst. I think the manganese dioxide acts as a catalyst there, speed up the reaction. So 2K MnO4, that is 2 potassium permanganate, yields on eating 746 degrees Kelvin. K2MnO4, which is potassium manganate and manganese dioxide plus the oxygen. And we have a method of collecting the oxygen over water. We set up that very famous apparatus with eating the potassium permanganate to give you potassium manganate and manganese dioxide and oxygen. Also, we have a very famous reaction. You have potassium plus oxygen to give you potassium peroxide. That is, the potassium react with the air to give potassium peroxide. And if you eat potassium superoxide, which is KO2, or if you eat potassium in the presence of a lot of oxygen, a rich oxygen environment, and what you call it, potassium plus oxygen, molten potassium, and super rich environment of oxygen, that will give you potassium superoxide. And potassium superoxide will further react if you dissolve it in water to give you potassium hydroxide, hydrogen peroxide, and oxygen. And that is to be differentiated from potassium oxide, K2O, which when dissolved in water to give you only potassium hydroxide. So those are some reactions of potassium with water and with air to give you potassium superoxide and potassium oxide and potassium peroxide. All right, we'll return with more of potassium a little later, but we just start off here with potassium. We must remember that it reacts just like sodium, a bit more powerful reaction with sodium and water. As you know, sodium run around and you put sodium in water there to give you sodium oxide as well, plus hydrogen. Same thing with potassium, give you potassium hydroxide plus hydrogen. So most of the reaction can be similar compared to the reaction of sodium. Only thing that potassium, I think, is more reactive in certain cases with the superoxide and the oxide and the peroxide. All right, so that's that. We will return with more potassium. But for the moment, that will be what we have for potassium.